So let's make a schedule for a factory. I'm building a web app for manufacturing plants called ProdPlan that allows them to do production scheduling. And I want to go run through an example real quick of what a plant manager might do to create a schedule. There's a lot to go into on each one of these tabs, but I'm going to skim through it just to get to the actual optimization. So a lot of this work, imagine, has been done up front by the factory. They've defined their tanks and their lines and their shifts. So this is batch processing, where you have large tanks that are mixing product raw materials, and then you have that product needs to be put into containers in order to get on a shelf in a store. So think of a cosmetic manufacturing, shampoos, conditioners, and lotions, for example, but that's one example of many product groups that is batch processed. And that product needs to go from a tank into a line. So you batch in your tanks and then you fill in your lines, and there can be a lot of other steps in there, more complicated, but really these are the two major steps in that type of manufacturing. So there's been some work done up front to define our tanks and our lines and we're going to go through and take a look at. So at this page, you're able to select which tanks you're wanting to schedule with. So these are all your tanks at your factory, but we want to use, let's say we want to run with 3 tanks, one of them specific to conditioner. Here's our run times and our setup times, and all that stuff can be edited. And here's which shifts are going to be available for those tanks. Let's change this one to be first and second shift. So we're running tank 23 first and second shift, tank 24 and 25 are just for first shift only. Likewise for the lines, let's just use 3 lines. Let's make this a 13 ounce only line, and let's say we'll run line 1 on first and second shift, and the other 2 just on first shift. Then we'll go to orders. So this would be all your orders that come in from your ERP system. Sync on your ERP system, so anything that's in your ERP system will show up in here. So, or you can add an order ad hoc. So imagine if you got a call from a customer and he said, hey, that product we've been talking about last week, what would it take to get 10,000 pieces of that to us by next Friday? Generally speaking, if you want to add that into your ERP system, who are you going to have to call? Somebody to add, and they're going to tell you, well, we don't have the BOM yet, and it's going to be a big hassle. But we want this to be not constrained by ERP system. We want to leverage all the data that's ERP system, but never be constrained by the ERP system, and always be a sandbox to let planners and production schedulers to the ability to do on-the-fly ad hoc analysis. So you could, if you wanted to add an order right now, put some information in there, check the box, and then that would be part of your schedule. But let's go down the line. Let's schedule for a few of these products, different product types and different amounts. And so we've got 1, 2, 3, 4, 5 different orders across, let's make that 6 orders across 5 different product groups. And then we have pieces here. This shows you how much on each of those orders, pieces wise, as well as the gallons that translates to the raw material. Going over to schedule. Now all we have to do is click solve and then run, and it's sending the problem is now sent to the solvers. We're only running a couple threads right now for the solver, but that will be potentially hundreds in the future. So we have solved. So what happens now is the solvers are generating solutions and incrementally building up solutions, and they're sending the results to the front end. So typically, obviously, your plant managers, this is for demonstration purposes, and plant manager would be only interested in the schedule that fills all the orders. But this shows you how the solver works to build up a solution job by job, optimizing each step of the way, but also and so as the solvers are generating solutions, they're live updating you on the front end. So each time we click on one of these schedules, the Gantt chart updates showing information about the schedule, and KPI, key performance indicators about that schedule. So we have tanks at the top here in the red, and then below that are the lines. The colors are consistent for across a product group, so all the red's product A, all the blue is product B, and you would fill this job and then batch before you fill. So there's constraints on how that production flow goes, obviously, but there can be other more complex constraints if you need them. And so as this thing is building up, we're seeing larger and larger solutions, or larger and larger schedules here. We have, how many days is this? 1, 2, 3, 4. So this is going on about a week now. As it's continuing to build. And so what's happening now in the background is it's creating good schedules as fast as possible, but then going back and looking for improvements. And so what you would have down here in the bottom is a bunch of options for plant managers to look at different schedules that make trade-offs for make span. The goal is to minimize your make span while minimizing also your labor costs. So anytime you run a shift, you're incurring the labor costs associated with that particular machine, line, or tank, and how many people it takes to run it, and how many hours for that shift times their rates. And that's all taken into account during the optimization. So it's attempting to wisely schedule as fast as possible, but understand that when you run a particular shift, you do not want to starve that machine during the shift. And so it's continuing to generate solutions, and you have key performance indicators about that particular any schedule that you select. You're able to select and dive into the performance metrics of that, showing things throughput, how many what percent of jobs on time, make span, labor hours, the profit, gross profit is really interesting, where you can now break down based off of this schedule the labor costs associated, broken down by product group. So that's something that a lot of managers would love to see, because it's very hard to do, understanding the labor cost for each product group, and that then translates into profit margin per product. So you could get into some very cool analysis there of which products are most profitable. And you can also, then that lends itself to thinking about, well, if our goal is to maximize profit for the month, then which products do we want to prioritize? And that would be shaping which shifts to run on which machines, and if there's specialized machines for certain products, as well as how long to run particular products, or so how, okay, let's go really hard on this one product because it's got great margins, whereas this other product has, maybe there's it's tight margins on this other product, so let's be more conservative on how we schedule and only make sure we run lines when we have plenty of batches lined up to fill. So be careful where we have tight margins, and then go really hard when we have great margins, and maximize the throughput of those. But that is, at a high level view, what it would look like, and it's continuing to generate solutions now, and there are better ones already. So these are higher profit solutions based off of, that's an even better one there. So it's going to continue to look, and think of it, while I have last few seconds here, think of a plant manager making very quick, good solutions, but then letting it run. And so, hey, I want to let this run for a few hours and to see if there's any better solutions. Or maybe I'll run this overnight because I have a really big, I'm planning for the month. But so that's I'd love to answer any more questions. Reach out to me at nate@natesolves.com, or right here, wherever you're seeing this video, just hit a reply, and we can have a conversation, do more demonstrations if we need to. Thank you.